Hey guys, Mrs. Horn here. I am making a short video today to give you some notes in your brand new Volume 2 notebook. I'm going to give you just 2 pages of information, so I'm going to keep it short. Problem is, I don't know what page we're starting on. I need you to get to the page that looks like this. It says relative dating. I don't think it's the first page when you open it up. You might have to scan a little bit into maybe the 40s. I don't know. Start with this page. So pause the video, find the page that says relative dating, and then when you're ready, hit play. Okay. When you look at a rock, or you look at layers of rocks, how old is it? How do you know how old something is? Well, that's what we're going to talk about today. We have this big fancy word called uniformitarianism, and it basically means that all things that are happening on the earth today have always been happening. So all geologic events that happen today, like volcanoes, earthquakes, plates shifting, transform plate boundaries, erosion, those are all happening today. But this principle of uniformitarianism means that they were happening yesterday, and 1,000 years ago, and 2 billion years ago. It means they've been happening forever. A guy that came up with this principle, his name is James Hutton, and I'm going to attach a short video to go along with this. My friend Hank Green is going to explain James Hutton and all of his cool ideas. So you can watch that after you finish the notes. We have this law called the law of original horizontality. The name of the law isn't really important, but the idea is this. When sediments are deposited in water, they form flat layers. This is how sedimentary rocks are formed. All sedimentary rocks are formed in water. Sediment is dropped down into the water. The sediment is compacted by the pressure of the water above it, and then over time, those sediments are cemented together. Well, over years and years and years and years and years, millions of years, you have lots of different layers, and they all form parallel layers, parallel to the surface of the earth. That's just a sedimentary rock. So when we think of the layers, which layer is the oldest? Which layer is the youngest? Well, by looking at the layers, we can figure out their age. We can figure out their relative age. And a relative age means how old is it compared to something else? So when we relatively age something, we're not giving it a definite number. We don't know exactly how old it is, but we might know that it's older than something else. Okay, so for example, if you take my 3 kids and you line them all up, could you figure out by looking at them who's the oldest and who's the youngest? Well, you might look at Evelyn and say that she's the youngest because she's the shortest. You might look at Sydney and she's the tallest, so maybe you'd say she's the tallest. You don't know exactly how old she is. You don't know how old Evelyn is. You don't know how old Garrett is, but he's somewhere in the middle. So you can relatively age them by looking at their height, possibly. Well, we can do the same thing with rocks. If you have some colored pens, this would be a great place to start using them. And all I did here was fill in the missing pieces. So I've got some rocks from 3 different locations, and I just drew in the missing layers by what matched. So if you want to pause the video right now and fill that drawing in, this would be a good time to do that. All right, here's the ultimate rule when trying to find the age of stuff in the earth. And I put a star next to this because this is probably the most important thing I'm going to talk about today. Here's the hint. The oldest rocks are always going to be on the bottom. Oldest is always on the bottom unless it's been overturned because of an earthquake or a volcano. Okay, so the general rule is that oldest is always on the bottom, youngest is always on the top. Bam, done. That's how we can age rocks. And that is my phone ringing. And I'm going to ignore that. Okay. We have a few more rules, and then this is the last page of notes we're going to do today. So another rule is that if there's a fault, so look, I'm showing you a fault here. If there's a fault, that's always younger than anything else. So we have all these layers, old, not so old, pretty young at the top. But you'll notice this fault happened after all of those layers were there, which means the fault is the youngest. Okay, another rule. If we happen to throw in an igneous intrusion, okay, that means that's younger than anything that was already there. So we already have all of these layers. Okay, 1, 2, 3, 4, youngest layer on the top, but this igneous intrusion came after the layers were already there. So the igneous intrusion has to be younger because it penetrated all of the layers that existed. These two words here are review, so we know what intrusion is, we know what extrusion is. Intrusion is when magma forces its way into the rock, which is in the earth. An extrusion would be rock that actually makes it all the way up to the surface. And, oh, this picture is showing different things that might happen to the rock layers. So this one might fold and have waves, which means that the folding or tilting, which is in this picture here, the layers of rock were already there. So the layers formed first, and then it folded. Then it tilted. Okay, so the tilting and the folding, that is the youngest. That is the youngest event that occurred. If we look at the sediments that make up the rocks, what's older? The sediment that makes up the rock or the actual rock itself? Well, it has to be the sediments. Sediments have to be older than the rock that they make up, because if the rock is already there, it was made from the sediment that came first. That is where I'm going to stop for today. I'm probably going to do a Google Meet later today. I'll post that link and my time so that we can chat and you can ask questions later today. Okay. I hope this helps.